Okay, so hello everyone. Today I will just brief you about the project and I will tell you what are the sub projects that we have under this. I will also share my screen, which is Paint. And so all of you know that we are trying to develop a system for a blind person. Now, for that, we have to come up with different software and hardware solutions. Uh, Currently, we have decided to work on, I guess, 8 solutions. Uh, those are machine vision based simple camera, then machine vision based 360-degree camera, stereo vision, depth camera. Then we have 3D LiDARs, 1D LiDAR, and then static LiDAR, and then ultrasound based system. And we also have, I think, infrared based systems. So I will just explain you one by one what are these things. So the first project is machine vision using a simple camera. So for that, basically you will have a USB camera. I think 1080p is the resolution of this camera, and it will capture some scene. This camera is connected to our NUC. Those who don't understand NUC, it's a very small computer that one can carry in his backpack, and that NUC will be powered by a battery pack, and there will be a speakers. Okay, a set of speakers, maybe 2 speakers. And what is the job of this team is to apply something called as YOLO, that is you look only once. And basically this algorithm detects whatever is the object in a, let's say there is a bottle, there is a table, whatever. So YOLO job is to detect the objects in the scene front of it, and then based on the confidence level, let's say it is 99% sure that it's a bottle, it can shout out loud that there is a bottle in front of you. And maybe that will help a blind person to understand what is to be done with those objects. Okay, so the bigger picture is, yes, you can tell people what is there in front of you, something very similar to what Iron Man's assistant do for him. So I think you might have seen this Avenger movie. So we are kind of making a Friday AI based assistant for the blind people, so that whatever is in front of it, it's get analyzed, and based on that the final decision is been spoken. So it's a very big project, and you can imagine the type of complexity. But the best part is software, it's complicated. Hardware you already have. So most of you might be having a laptop with a built-in camera. So that's all. That's the bare minimum hardware requirement. You might have a headphone to speak out text to speech. So there is 3 parts to this project. One is someone has to build a speak out or text to speech model. There are ready-made models available to do that. Somebody has to try the YOLO model or build their own model. So this is the first project where we'll try to define. Now again, there could be one more sub project to this where we build a reader for the blind. What is this reader for the blind? Your text on the screen or whatever book the blind person holds in front of it, the system should able to read that book for the blind person. So that could be the next level of this project. Again, we are going to build this cap. So the cap will have a LiDAR, a camera, everything mounted on it. We might have 2-3 versions of the system. So this is the cheapest one, because the USB camera, as you all know, will cost you roughly around 1200 rupees. Currently, I guess from the market, we have ordered 10 or 1500 rupees camera. But later on, we can bring this cost down also. There are some very good camera by manufacturer Siri, which are currently out of stock because of the export restrictions. But we can definitely have a exploration on other cameras also, which are cheap and easy to use. Okay. So for reader, you need a high resolution camera. For detecting objects, we can even work with 640 cross 480 camera. So smaller the image, faster is the image processing, better is the chances of detecting object on a, what I can say, on a raw level. May not be a detailed version, like it can say it's a bottle, but it may not able to tell whether it's a Coca-Cola bottle or a Bisleri bottle, and so on and so forth. So you can say a coarse level detection, and then we can go for a finer level detection. So this is the first project. I hope it is clear to team one. I don't know who is team one right now, but Atharva will be taking care of that thing. So you can join this team. There are multiple tasks inside this team. Text to speech is there, automatic readout is there, OCR is there, YOLO is there, and so many things. Okay. Let us move on to the second part of this project. So second sub project under this system for blind is machine vision using 360-degree camera. So for those who don't know about 360-degree cameras, I will just try to show you something. So 360-degree camera. So these are the cameras which have a fisheye lens on both sides, and they typically cost you around 10,000. So I think these are a rotating 360-degree camera. This is not what we are talking about. We are talking about what we can say panoramic. I have to check. Yeah, this is one of the 360-degree light bulb, but we don't need that also. I think I have one from the Samsung brand, so I will just search for that. I think it's not available right now in the market. So basically, two fish eye lens are there, and if you check the images with this 360-degree camera, I just have to check what is the Samsung 360-degree. Yeah, this is the one I have, Gear 360. So let us put that word. Okay, so I don't know, some market price will tell you 17,000 Insta 360. But we are going to use this Gear 360-degree camera. 9,000 something. Yeah, this is what I was looking for. And images with this, I will just see if I can show you some of those images. This is pretty new field, and 360-degree cameras are very new to the market. So this is the kind of image you get. This is from the front and similar image from the back. So then you use some image stitching algorithm to get a 360-degree panoramic shot like this. So this is like, these are like stitched images, 360-degree, and these weird images, basically you have to do now the object detection inside these images. So basically it's a different level of what you can say image processing, and you might have to first do the correction from circular geometrical system to a Cartesian system, and then based on that we can do the further analysis. So this is the kind of images that we get through this 360-degree software, and these are the type of the cameras what we are talking about. So for image processing, I have this camera with me, so I will give you thousands of images if you want, and you start processing them. It will again use a similar concept to the first project, except now readout may not be necessary. So let me go back. So the only change from the second project and first project is that there is more complex algorithm. Your images are now around two rounds like this, one from the front and one from the back. And basically you have a camera mounted on top here somewhere on the head, and then you have one camera facing front and one camera facing back, and you have to describe the room to the blind. That is the kind of a task I will expect. I will not expect this camera to have text to speech conversion or readout. Okay, so it may not have OCR into it. OCR stands for optical character recognition, where you read out the text to the user. But I will still expect people to first do the correction and apply something like YOLO. May not be this algorithm. This is just one example I am giving. You can use any OpenCV or image processing algorithm to detect the objects, to classify them. And that is about the second project. I don't know who are the team members for that project again. Atharva, and you can take care of that. So let us go back to the third project now. Third project is a stereo vision. Now the concept of stereo vision is even what you can say fascinating, and this is a stereo vision, but this time 360 degree is also a stereo vision, but this time we will have two set of cameras spaced at exact a distance of eye, like 6 centimeter apart, 6 to 8. Okay, and then you have two images from two cameras, and now along with your object you should able to perceive how far is the object from those two cameras, because you will have a difference between the two cameras and you can apply some mathematical geometry. So you will have RGB, and then each of the object will have its own depth corresponding to that object. Okay, so RGBD. Now we get direct cameras like that, but they are very costly. Minimum cost of such camera is 20,000. So you can imagine the depth camera cost you 20,000. This individual camera might cost you around 700 to 1,000 rupees, and you need two of them. Okay, so same task, if I can do it at 1,400, everyone will prefer this. Okay, so just a software, that's it. Software and some geometry, basic geometry, and based on the two images you have to stitch the edges, and then how far the edges were from the origin point you can choose. Based on that you can decide that the stitching is to be done in a certain manner. So again, a complete software project. For this, you may not have a hardware. Like second project also, you don't have a hardware, but I will provide you the images. For this, you may not have a hardware. Those who have a desktop in their home, they can take out the webcam from that, and they can place the webcam in such a way that it is 6 to 7 centimeter apart from their regular webcam in a laptop. So they have to connect a USB webcam to the computer. They can use two USB webcams, I don't mind, but if anyone has one USB webcam, they can proceed with this. Else we will purchase the USB webcams for you. We will build this stereo system, give it to you, and maybe we will provide you with the image data set for same instance, image 1 folder and image 2 folder. So you will have image 1 and image 2 folder. Because of this pandemic, we are not handing over this hardware to you or the team, but later on, as soon as this third wave of corona goes away, we will hand over this hardware to you and you can proceed with this. Okay, so that is the third project what we are working on. Again, hardware is I have with me. I have a webcam, webcams, a pair of webcams, but I think we should order the identical ones. So I have two separate webcams by different companies. I brought multiple webcams just to compare their quality, and then I found out that Sri Home is the better one. Even I brought Logitech and HP and tried multiple branded cameras also, but somehow this Sri Home camera was much better than others. So currently again it is in shortage to the market, but we will try to get identical cameras for this. Next is the depth camera. Again, we know that the entire world is going through a silicon shortage, so depth cameras are there available, like Intel RealSense. This camera is getting, its cost is 20,000, but because of this silicon shortage, currently it is being sold as 45,000. So I don't want to purchase a camera at more than twice of its own price. So we will wait for this silicon shortage to go down, and we will wait for this camera price to fall. But this particular camera not only uses a stereo vision like what we are developing, it also uses an infrared transmitter receiver to give you a true depth. Okay. So with your two eyes, you can do everything. I know that, but if you have infrared, it can sense the depth even in the night mode. So night vision is also possible. And also it senses infrared heat transmitted from the living objects. So it can also be used to detect whether it's a human in front of it, or a cat or a dog or any living animal, or whether it's a table or it's any passive infrared heat. So you can read about this sensor, and those who are working with this project unfortunately have to wait for or they have to find a website where this camera is available at cheaper price, and then we will go ahead and purchase this thing. So again, there are options like Kinet is there, which is like 14,000 rupees. So if you feel we don't need Intel RealSense and you can work with Kinet, I will go ahead and purchase that for you. And you let me know what you need. This team has to work. So what will happen is, if I have RGBD plane, then I can tell the blind person that there is an object coming in front of you at this distance. So the depth sensing has to be there. So that's how we are going to use this kind of cameras, depth camera. So whatever algorithm team 3 is developing, it's already being developed, it's done, and it's already inside this small camera in it. So this camera has a processor inside it, and it can directly give you the depth map also. So RGB map is not of interest to us, but the depth map is what we care about in this particular case. तो बेसिकली टीम 2 फेल होगी एस्यूम करके ही हम ये पैरेलल अप्रोच ले रहे हैं. तो टीम 3 अगर सक्सेसफुल होती है और दो यूएसबी वेबकैम से वो बेटर डेप्थ निकाल पाती है, तो दैट इज नथिंग लाइक इट. ओके, एंटायर वर्ल्ड वांट्स दैट सॉल्यूशन. सो टीम 3 हैज अ बिग स्कोप. If they develop this camera system can be used in autonomous vehicles, in any system where the computer vision with depth is required. Okay, so yeah, you are actually trying to kill this product. Next project topic or sub project topic is 3D LiDAR. Again, this 3D LiDAR is very costly equipment. It is currently only Velodyne is the company who is selling this, and we are in constant contact with this company. So Velodyne LiDAR has static as well as dynamic 3D LiDARs. So what is the 3D LiDAR? Basically, instead of firing a single wave of laser and reflecting back, it fires a multiple lasers at different wavelength. And I think up to 32 or 128 scans it can do simultaneously. So yeah, there is a video, I guess. So this particular 3D LiDAR is used in most of the cars, and that's why autonomous cars is going to be costly. And yeah, I think they have mounted it on a quadcopter also. So there are many ways you can mount the LiDAR system, and they are like multiple scanning systems. And I think they will show some output. Yeah, you can see the kind of output they got with this LiDAR. This LiDAR has moved around the statue, and entire statue's 3D representation was done like this. So this is the very fascinating technology. And what happens is, with this 2D LiDAR, I have this in my hand. So with this 2D LiDAR, what happens is it shoots the laser, and then it catches back and rotates so fast that it shoots, catch back, shoot, catch back. So everything happen in a 2D plane. So This is a 2D LiDAR project, which I will explain soon. But then you have a 3D LiDAR where it shows a rays of light, like 16 lasers at a time at different angles with different velocity and wavelength. And then it senses back those 16 simultaneously back. So we will have a 3D room around it through this LiDAR. Something similar to this statue, may not be exactly like this, but this is how a 3D sensing is done with the LiDAR. So we have budget, but we have roughly 1.5 lakh budget for this 3D LiDAR. So Velodyne LiDARs are well above that. And we are trying to get this LiDAR for our work. If not, there are Chinese 3D LiDARs available, static 3D LiDARs. Each will cost us around 37K. So we might purchase 4 of them and connect at static LiDAR. So they do not rotate, but they are 3D. So we might connect 4 of them around the cap. Coming back to the next project. So 3D project team might have to wait. They have to bargain with different vendors and they have to come up with their own solution. So this is a hardware based project. So this will be slow, but I would expect people to work on this. Then we have 1D LiDARs. So these are the static LiDARs like this. Basically, it's a single beam thrown, and wherever it finds object, it reflects back and tells how far is the object. Up to 12 meter or 8 meter is the range what I have got. It's called TF. I think it's called TF Mini or TF Luna. TF Luna. TF stands for time of flight sensor. So it basically throws a light and it requires another sensor. So whenever that light comes back to that sensor, it measures the time of flight, and based on that, and the distance is computed. Next is static LiDAR, which I have shown. I don't know. So 1D LiDAR, this is basically a 2D LiDAR. So why is calling static LiDAR, I don't know, but I think this is what we meant by this. So 3D, then 2D, and then you have 1D. So basically now you have live rotating object. I think I can show it to you right now also. So I just hold this LiDAR in my hand like this, and I connect it to my USB port. So it's rotating now. Cannot be visible to you, but it's rotating. You have to trust me for that. And you can see the laser has been thrown live. And now let us see how it can measure the distance. We have some tool for it, LiDAR viewer. Okay. Some free tool is there. So I have connected it to COM4. X2 is the type of the LiDAR we have. And now it should able to show me my room. So let's start. Yeah, I can see that. It's showing the entire room around me. And that is my hand. And I can also see the angle, a different angle, how far are the wall from this particular point. So this weird shape is me sitting in front of you. And this is how, if I hold myself close to my mouth, it will also catch my nose and all. So this is the thing what we are going to mount on the head. You might have seen my first video on YouTube. If you have not, please go and watch that. And then yes, obviously you can see this is the thing. We will give you the data points, but this is a hardware thing, so we might expect the students to travel for this particular project. So that is where I think 3D, 2D and 1D LiDAR is clear to you. And then you have ultrasound sensor, which has not yet arrived, but those are the low cost solution. This is Arduino based hat. So you just put 4 ultrasound and then you walk around. Whenever you see an object in front of, It just makes a beeping buzzer. So very low cost solution. Ultrasound sensors are roughly 200 rupees, not more than that. And then we need a Arduino to detect those. Maybe some multiplexer to swap between the sensors, and that's it. So these are the different projects. And if you have any doubts, you can ask now.